Hello. Um, so we are going to start the first measure of variability, the range. By the way, as I said in the previous videos, I lost a set of videos that I recorded already because the audio was not recorded. My voice was not recorded in the videos. So I look at this. I have two monitors, and I put the audio monitor here. So please understand, I may like look back and forth to check if my record is going well. Anyhow, so the range. Let's talk about the range. The range is the most intuitive and easiest to understand measure of variability. It is defined as the difference between the maximum and the minimum of the data. So in the previous video, when I compare Honolulu and Arizona, the difference is clear when you compare the coldest weather and the hottest weather. So Honolulu changes the temperature in Honolulu varies this much, but in Arizona it varies this much. So when it gets cold, it gets colder. When it gets hot, it gets hotter. So the maximum is greater, the minimum is lower. So the range is bigger. The difference between the maximum and the minimum is larger. So obviously, the bigger the range is, the more interval the observations range. So the data are more volatile. It varies more. In our example, the calculation is also very simple. In Honolulu, the maximum is 87.9 in July, but the minimum is 66.3 in January. So the difference is only 21.6 degrees in Fahrenheit. Throughout the year, the monthly average varies only by 20 degrees. Paradise, right? So that's why Honolulu is the best place. I have been to Honolulu once. I want to go there again. Yeah, but meanwhile, Phoenix, the maximum of Phoenix is 106.1, very hot, and minimum is 45.6. So the variation throughout the year is 50.5 degrees in Fahrenheit. The variation is even more than twice larger than that in Honolulu. So Honolulu's variation is around 21, 22 degrees a year, but Phoenix varies more than 50 degrees. That if you so to summarize the difference between Honolulu and Phoenix in one number, I would use this one, right? So it's easy to understand. Well, right, clearly very intuitive, very easy to calculate, very nice measure to present to show the difference between Honolulu and Phoenix, very contrasting to each other. But the problem is, in this example, this is not bad. It's very nice. But in economics, you have to be more careful because the range is extremely sensitive to outliers. I'm going to explain why. In our example, it's about temperatures. So in temperature data, outliers are rare. Like you never see like 200 degrees or minus 100 degrees at all. But in economics, we have them like super rich and some extremely rich guys screw up your analysis. So be careful. To illustrate what happened when there are outliers, think about this data. I simulated data. It's a histogram. The sample size is 99. It has 99 observations, ranges from minus 1.8 something up to 2 point something, right? So if you calculate the range, it is 3.67 something, right? So there's a minimum and the maximum is easy to see, and their difference is the range. But now suppose that so sample size was 99 and you add one observation, which is an outlier, quite far from the second smallest one. So this outlier is about minus 2.8 something. This outlier makes the range increase to 4.79. Compare, it was 3.67, but now it's 4.79. Increases by about 1.1, which is like 30%. So just one observation out of 100 changes 30% of the measure. Also, it's a problem. This is never ideal in any case. So the outlier causes a big problem. And in economic data, we have much more extreme outliers in many data sets. Like Bill Gates would be out of this graph, like outside the chart. So then the range is meaningless because just it does not show the exact how much the data are how the data vary. It's just only one observation vary at this point, so that's not capturing the variation correctly. So as an alternative to the range, we have a modified version of the range. Still range, other than the outliers, other than that problem, the range is very useful, intuitive, simple, easy to explain, easy to calculate, so very nice in many aspects. So we modify the range to overcome the problem. So we make an interquartile range. So before defining interquartile range, let's review what we have learned in the previous chapter. Quartile is to divide data into 4 parts. So you divide data into 4 parts into 4 parts of the same size. So the first cutting point is the 25 percentile. So it cuts out the bottom 25%. And the second cutting point is the median, which is the second quartile or the median or the 50 percentile. So it takes the second, fourth, and the third cutting point is the third quartile, which divides the bottom 25%, or so it's 75 percentile. So imagine by cutting the data at 3 points, it divides the data into 4 parts of the same size. We call them the cutting points as quartiles. So there are only 3 quartiles. And then what we are doing here is we cut out the data again. Trim out bottom 25%. And also trim out top 25%. Bottom 1/4 and top 1/4 are deleted. Literally, you delete them. Then you only have 50% in the middle, from 25 percentile up to 75 percentile. So by trimming out the bottom and the top, you are deleting all the outliers. Outliers cannot survive the trimming, right? So when you use the middle 50%, you don't have any outliers in the middle. So then what you do here is using the middle 50%, calculate the range, calculate its maximum and its minimum, and take the difference. That is the new range, which is defined as the interquartile range. Because of the trimming process, trimming out outliers, it is very, very robust against outliers. So interquartile range is the most robust measure of variability when there are outliers among the 4 measures we studied today. So then simply put, when there is the most common pair of measures is the mean as the measure of center and the standard deviation as the measure of variability. But these two measures have problems when there are outliers. So when you are concerned about outliers, you may consider the median as an alternative to the mean and the interquartile range as an alternative to the standard deviation. These two, median and interquartile range, are could be better choices when there are outliers. To visually demonstrate what happens, think about the previous data set. There are 100 observations. Outlier is here. Anyhow, without looking even doesn't matter where the outlier is. You are going to trim that out. You will delete bottom 25%. So you delete the 25 smallest observations. They are these orange observations are deleted, and also on the other end, you delete the biggest 25 observations. The largest 25 observations are deleted. Then out of 100 observations, you only have 50 observations remaining. And when you do that, the cutting points are first quartile from the bottom and third quartile from the top. You are cutting out this and this. So your data set now looks like this after trimming out the top and bottom. So all the outliers are gone. And assuming this is your data, you calculate the range, calculate the maximum and the minimum, and take the difference. That is the range of this data, which is 1.13. This is the interquartile range. And then obviously, because the cutting point at the top was the third quartile, the maximum of these observations must be the third quartile. And the minimum of these observations, surviving observations, must be the first quartile because that's where you cut out, right? So interquartile range is the difference between the third quartile and the first quartile. Third quartile minus first quartile is the interquartile range, right? So in this video, we defined two measures, the range and the interquartile range. They are very easy to understand and easy to calculate and intuitive to explain. So these two were based on percentiles. Minimum and maximum are also percentiles, 0 percentile, 100 percentile. And obviously interquartile ranges based on 25 percentile and 75 percentile. And in the next video, I'm going to define variance first. And that is based on the mean. So it will be totally different from what we have done in this video. So I'm going to continue in the next video. And I will stop the video here. Thank you for listening. See you.